Student, now is it audible? Is it audible and visible? Students, is it audible and visible for you? Board is visible, right? So someone had asked to repeat this step 5. So why you are getting confused? I am explaining all the way that how we are going to be obtained our fifth step. In generally, what happening in auxiliary method? What happened? All of you just see auxiliary method. So you are going to have only 5 steps. All of you just remember that. Stage 1 and stage 2 are as similar. Stage 1 and 2 are same as change of position method. Okay, so but the only difference is, so 5 steps you are going to be complete your problem. So in first 2 stages you are going to, here it is stage 1 and stage 2, right? So in stage 1 and stage 2 you are going to obtain 4 steps. So let us say 1, 2, 3 and 4. So in this 4th is going to be one of your final view. This final view means where it is front view. So if it is below XY, it is top view, but it is above XY. So it is my final front view. So what I require final top view. So final top view is going to be required. Okay. So let us see. So 4th and 5th are final steps. Final steps. Okay, I already have my 4th. How can I obtain 5th means? First of all, I just find my alpha. Why? Because in the problem he just gives diagonal is making inclination. When he just gives directly diagonal is making inclination, we had to find apparent angle. Okay, once I find apparent angle, I obtained alpha. You just extend the diagonal A dash D dash to some extent and draw new reference line x1 y1 with the obtained inclination alpha. So whatever your alpha is obtained, so draw a line of A dash D dash and extend such that the inclination is alpha. So this becomes your new reference line x1 y1. x1 y1 becomes your new reference line. Okay. Now draw the perpendicular projectors from all the points to the new reference line. What are all the points means? Nothing but your 4th step. So here it is your final top view. Final front view. So from the final front view, draw the vertical projectors perpendicular to new reference line x1 y1. Let us see, all these are perpendicular to new reference line x1 y1, and I am supposed to extend these lines. Now simply take, so my requirement is top view. What is our reference top view? General here it is going to be our reference top view. So now take this is the old reference line x1 y1 and these are the points. These are also going to be perpendicular to each other. Okay. Now take the distances from the old reference line to that point and take it from the new reference line and mark the points on the projectors. Let us see, A point is already on X line. So this was my A projector. I put my point A on x1 y1. F and B are some distance away from old reference line. So I just take that radius. And I take the centers from the new reference. So this was the projector of F and this is the center and draw an arc. And similarly B, let us see, this was the center from new reference line and draw an arc. Similarly, from old reference line to E and C are going to be taken as radius. This was radius. And take the projector of E and C. This is E, this is C. Take it from this as center, draw an arc. Similarly for C projector, this as center, draw an arc. Next, take this D point from the old reference line. The distance is going to be taken as radius, and this was the center, and measure the radius, and take it from the new reference line x1 y1 Okay, this is your D and now join all the points. You will obtain final top view. This becomes your fifth. So fourth and fifth are final views, which are final front view and final top view. Okay, students, is it clear now? Is it clear now? So can I erase this? Students, can I erase this? The participant strength is very poor. Now we are supposed to start very important chapter, projection of solids, but the participation is very poor. So how can we proceed? I am not able to understand. Now with the participant half of the strength. For these sections it is 180, okay, but I am just seeing only 90. So students, today we will start the new chapter of solids. Okay. So tell me, what is the difference between your planes and solids, which we discussed until now? We discussed about the what is the difference between planes and solids, students? So we can say that planes are having how many dimensions? The basic difference is how many dimensions it have. It have only length and breadth with negligible thickness. The planes are going to be having length and breadth with negligible thickness. While coming to solids, you are going to see length, breadth and thickness. So for that only planes we are calling, planes are two-dimensional view, two-dimensional objects, while coming to solids are three-dimensional objects. What are those three dimensions? Are nothing but your length, breadth and thickness, or length, breadth and height. Okay. So let us see. Until now, we just see the plane surfaces. We just see only the shape without having the thickness or height. Okay. Now, in this type of projections of solids, we are going to be take directly solids. Okay. So these solids are mainly classified into two categories. Solids are mainly categorized into two categories. What are they? What are they? Solids are mainly classified into prisms and pyramids. So what is the difference between prisms and pyramids? Okay, we already know about the prism and pyramids. What is the difference between these two, prism and pyramids? What you can notice the difference between prism and pyramids? Anyone? Anyone had put a message? What is the major difference? So let us see. We already have an idea about the pyramids, like we already generally aware of Egyptian pyramids, right? So while you are going to be see the Egyptian pyramids, can you tell me what was the shape of that pyramid? What was the shape of that pyramid? What was the shape of that pyramids which we seen in Egypt? Egyptian pyramids are in cone shape. Cone. So when you are supposed to see from front view, what you are going to be seeing? So triangular faces, triangle, yes. When you are going to see from the front, you are going to be seeing the pyramids are going to be, it is going to be in the shape of a triangle. Okay. But what we can name it? What was the name of that pyramid? We can't say it is a triangular pyramid. The pyramid is a square pyramid. A pyramid is a square pyramid. How can you say it is a square, sir? When you are going to see from front, you are going to notice a triangle. Okay, but how can we say it is a pyramid is of a square pyramid? So that means where you are going to be see the true shape of the base. Okay, whenever you are going to see the true shape of the base, then only we can name it by that shape. If you see the Egyptian pyramids in general, while you are going to see the front, you are going to be see the only faces. Only faces. Those faces are triangular faces. For pyramids, you are going to see triangular faces. Okay? But how can we name that pyramid, sir? I name it as a square pyramid. How can you say that? So that means whenever you are going to be see from the top, you are going to be have the shape of a square. Okay, according to the base shape, according to the base shape, we give the name of that pyramid. So that means pyramids having triangular faces, and according to the base shape, we give the name of that pyramid. So the pyramid, when you are going to see from the top, you are going to be let us see, here it is going to be seen, when you are going to see a pyramid, when you are going to see from the front, you just only a triangular shape, that is nothing but a face. Okay? And how can you say it is a square pyramid, sir, when I am supposed to see from the top? Let us see. If you see in this manner, you just see the base shape as base shape of square. So I consider it as the square pyramid. Okay. Now, if the base shape is going to be pentagon, and if pyramid is going to be like this, base shape is pentagon, then I can name it as pentagonal pyramid. Okay. Now, all face triangle, all are triangular faces. According to the base shape, we name that pyramid, and all edges are slant edges. Let us see. If you consider the pyramid, okay, the edges are not straight. These are slant edges. You are going to see the slant edges. All the edges are slant edges. Okay. And you can see that all these slant edges are meeting at a common point called apex. Okay. All the slant edges or all the faces are going to be meeting at the common point apex. All edges or faces meeting at apex. Okay, common point called apex. And you just notice that, okay, so this was going to be having an axis joining the center of the base and apex. So are you going to see this axis of the solid? No, it is imaginary. Okay, so axis is going to be obtained by joining of the center of the base and apex. Axis obtained by joining apex and center of the base. Okay. So generally we are going to be discuss about these three categories, and another category we already have was solids of revolution. Solids of revolution also, generally prisms, pyramids, and solids of revolution. So what are these solids of revolution? So that means the solid which is going to be obtained by revolving a surface for 360 degrees. Then you can obtain is nothing but the solid of revolution. Okay. Next, we already know that now it is going to be pyramids having what kind of faces you are going to be seeing? Triangular faces. While coming to edges, it is going to be slant edges. And how can we name that pyramid? Means according to the base shape only. Okay. And you can see that all the base edges are going to be, edges are slant edges. What is this? How can we obtain the edges? And the slant edge is going to be obtained by joining the base corner to the apex. Slant edge means slant edge. How can we obtain joining? Slant edge means joining base corner to apex. Joining the base corner to apex, you obtain slant edges. Don't get confused. Okay? And all edges and faces are meeting at a common point called apex. Let us see. All the faces, triangular faces. All faces are triangular faces. Okay? All faces are meeting at a common point, apex. Axis is going to be nothing but imaginary line joining the center of the base to the apex. Next one is prisms. How can we differentiate a prism from pyramid? So, the pyramids having only one base, having only one base. Pyramids are having only one base. While coming to prism, you are going to see two bases. Let us see. So this was a prism. How can we name this prism? This prism is a pentagonal prism. Why, sir? The base shape is going to be a pentagon. Then we can say this is a pentagonal prism. So this pentagonal prism having two base shapes. Okay, or two bases. Okay. Next, having two bases. Next, while coming to faces, let us see what was the shape of the faces. What is mean by faces? Tell me first of all, what is mean by the face? Here it is going to be the face means let us join the base edge, one of the base edge to the other opposite edge is going to be get joined. Okay. Then it is nothing but base edge having two corners, and here it also having two corners. If you joining these two corners, that you are going to be obtain a straight line. So if you join all these things, you are going to be having the faces. This face is going to be shape of a rectangle. Okay. Now we can see here having only one base. Here it is having two bases. Okay. And all are triangular faces here. Now here it is all are rectangular faces. Okay. So similarly, according to the base shape, we name the same. We name the prism according to the base shape. Next, while coming to here, all edges are slant edges in the pyramid. While coming to here, all edges are straight edges. Let us see. Here it is a pyramid. So it is a prism. So this was a prism having edges which are straight edges. All the edges are straight. Next, here all edges and faces are meeting at apex while coming to pyramids, but here there is no apex. There is no apex. There is no apex. Why? Because they are having only one base and one apex, while coming to here it is having two bases. Okay, that is two bases. Next, axis is going to be obtained same. Axis is going to be obtained by joining of two base centers. Okay, let us see, this was one base and this was another base. Let us take the center of this base and let us take the center of the top base. This was bottom base, this was top base. Let us take the centers of two bases, and if you join the line which is going to be joining those two centers, you will obtain the axis. Okay. Next one is nothing but your solid of revolution. What is mean by the solid of revolution? In general, the prisms are going to be name it as triangular, okay, square, pentagon, cube, hexagon, okay, etc. Okay. Similarly, while coming to here, the pyramid is also going to be as like as, you can also get the same shapes as like of the prisms, okay, triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid, etc. Okay. Now, okay. Now, what are the solids of revolution? So we already know the solid of revolution. Now, what is mean by the solid of revolution? Rotating the surface for 360 degrees. Surface, okay, or generator for one revolution. So simple example is nothing but your cone. Okay. So that means let us take a right angle triangle, and if you rotate for 360 degrees, okay, you are going to be obtain a cone. Okay. So this is nothing but your apex. This was the base. Okay. So solids of revolutions are nothing but your cone. Next, cylinder. Next, sphere. So general shapes we are going to be seeing in solid of revolution. SOR, solid of revolution. Cone, cylinder, sphere. So that means, so here you are going to have your cylinder is also comes under prism, and cone comes under pyramid. Okay, cylinder and cone. So cylinder we are going to be considered in the classification of the prism, while when you consider for the cone, it is comes under the classification of the pyramid. Okay, students, had you understand the difference between the prism and pyramids? So the main important thing is here also we just what we discussed in the projection of planes, the same routine procedure we are going to be follow here also. What was that change of position method? In the change of position method, what are the three stages you are going to be look over? What are the three stages? Stage 1, stage 2, stage 3. What are those stages? Stage 1, 2, 3, simple position, surface inclination, and edge inclination. Okay. Similarly, here also, we are going to be consider in these problems of solids. He just gives axis inclination, that is solid is going to be inclined. When the axis is inclined means, the total solid is going to be get inclined. Why? Because axis is the imaginary line which joins the two centers of the bases of the prism, or joining the apex and the center of the base for pyramid. Okay, so if the axis is going to be just tilted means the total solid is going to be get inclined. Okay, so in the simple position, what we just considered in the projection of planes, let us assume your plane surface is parallel to the reference plane to which it is inclined. Similarly, here also, let us assume for simple position, for starting of the problem, let us assume where the surface of the solid is inclined. Surface in the plane. So while coming to here, axis of the solid, the total solid is inclined. So let us consider the axis is inclined to HP means let us put your axis is perpendicular to that reference plane. Okay, here whenever all of you just remember, when your axis is inclined to HP means for simple position, let us put your axis perpendicular to HP. That means if your axis is inclined to HP like this means let us put your axis perpendicular to HP. Whenever your axis is perpendicular to HP, then only we are going to be see the true shape of the solid from the top view. Okay? So the projection of solids is going to be completely depends on the axis inclination only. Okay, so always you just remember this axis is going to be inclined or axis is perpendicular to one reference plane and inclined to other. Okay, so like that, this was completely based on the axis inclination is going to be very important. Let us see a simple problem for your understanding. Pentagonal prism is taken, is resting on HP with one of the base. Let us say this was the base. Resting on HP with one of the base, edge on ground, and axis inclined some 45 degrees to HP like this. Okay, like this. So in this consideration, how can we put the simple position? Axis is inclined to HP. Let us put your axis is perpendicular to HP. Top view gives the true shape. We have to start from the top view. Front view, what you are going to see from the front? You are going to see the straight edges and rectangular faces. But true shape of the solid is going to be seen from top. Okay, and here the axis is inclined. How many degrees? 45 degrees. After that, the edge which is resting on the ground, is making an angle of some 30 degrees to VP like this. The problem is going to be given in this. So here also projection of solids 1 and 2. That means axis inclined to one reference plane, axis inclined to both the reference planes, as we discussed last same as in the planes. In planes also he just gives surface inclination and edge inclination. Here he gives axis inclination and the edge inclination. So edge inclination means always the edge or corner which you are going to be assumed in the problem is going to be resting on the HP or VP is to be rotated for the second inclination. First inclination always you consider for the axis inclination. Okay students, is it clear? Is it clear? So let us see any problem. Let us start a simple problem, then you can easily understand. Shall I erase this? So we have another type of solid also. which is nothing but we can see the frustum. We can call it as frustums. What are frustums is nothing but the sections which are going to be the section of a solid which are going to be obtained for cone and pyramids. So let us take a section plane parallel to base, and if you suppose to cut the solid in such a way that if you remove the portion in between the observer and the cutting plane, then the portion retained is called as the frustum. Okay, so another kind of solid is frustum. Frustums. So frustums are nothing but the frustum is nothing but, let us see if it is a cone. You already know about the cone. If you take a cutting plane, so this was a representation of the cutting plane. Okay, so that means thick at ends and thin at center. Okay, if you take the cutting plane, so this was called it as VT. Why? Because whenever you take the vertical cutting plane which is perpendicular to VP, if you notice as a straight line, then it is going to be your trace VT. Okay, perpendicular to vertical plane. So if you remove the portion here, this portion is always here is the observer, and when you make your section, always you just have to remove the portion between the observer and the cutting plane. This portion is removed. Okay, then you are going to obtain. So this is nothing but frustum of a cone. So this was the frustum. So that means frustums are nothing but a sectioned solids such that a section plane is supposed to cut the original solid. After the sectioning is going to be completed, if you remove the portion between the observer and the section plane, the retained portion we call it as a frustum. So here we can consider it as the frustum of a cone. Why? Because the base shape is going to be, base shape is in circle. So we call it as a cone. So here it is going to be frustum of a cone. If the base shape is of a hexagon, so hexagonal pyramid is going to be seen. So hexagonal pyramid is going to be taken, or pentagonal pyramid is going to be taken. Let us see. If you just take the cutting plane from here, and if you just cut this portion and you just remove it, and when you see from the top, you see the section portion. When you see from the front, you are going to have only the obtained is nothing but your frustum. Okay, all of you just remember the frustum. No problem. You can go through the textbook also. You can see these kind of figures. All of you draw the simple position. First of all, we just have to learn the simple positions of the solids. Without knowing the simple position of the solids, we can't do anything. So that means draw the projection of a square prism. All of you just write this problem. Draw the projection of a square prism. Of side 30, of side 20 mm side, and height 50 mm, and height 50 mm, resting with base with its basing on with its base on HP, resting with its base on HP, such that one of the rectangular faces is perpendicular to VP, such that one of the rectangular faces perpendicular to VP. And the nearest edge is parallel to VP and 50 mm in front of VP. Nearest edge is parallel to VP and 50 mm in front of VP. Is it visible clearly? Square prism of side 20 mm and height 50 mm, resting with its base on HP, such that one of the rectangular faces is perpendicular to VP and the nearest edge is parallel to VP and 50 in front of VP and 50 in front of VP. So what is this? This was a square prism, right? So anybody have any idea about this? Anybody have to how the solution is going to be? So he gives a square prism. So square prism means having, so prism means first of all it is having Let us see a square prism having two bases. This was a base, and shape of a square. So I call this as a square prism. Okay. So prism means all faces are rectangular faces and all edges are straight edges. Okay. Now square prism of side 20. So that means base side of a square 20. This is side 20. This is also side 20. Next, height of the solid is given. Height of the solid, which is given as 50. So height is 50 and the square side is of 20. Resting with its base on HP. So base is resting on HP like this. Base is resting on HP. Next, such that one of the rectangular faces is perpendicular to VP. So if you put like this, you can see that, okay, so you are not supposed to make it some tilt for some degrees or like this. Why? Because then one of the edge is going to be making inclination. But what he is asking, one edge is making inclination means this rectangular face is also not perpendicular to VP. That means it is making inclination to VP. So now how the condition satisfies means you just put your square block in this manner such that the base edges, these base edges are going to be parallel to XY. Base edge is parallel to XY or the base edges are parallel to HP and VP. Base edges, let us see. If you consider these edges, you can see these edges are going to be parallel to both the reference plane or parallel to XY. Okay, and if you put like this means this rectangular faces are also perpendicular to VP. And at the same time, the nearest edge is parallel to VP and 50 in front of VP. Nearest edge parallel to VP means, so this is going to be the farthest edge. So opposite to this edge, that is at here. Opposite to the edge which is opposite to here is from VP it is 50 in front of VP. So 50 in front of VP. So which gives the true shape of the square prism here. Base is resting on HP. So top view gives the true shape of a square and front view gives the height of the solid. Okay. Now let us see. He just gives 50 in front of VP. I just draw a line of 50. Okay, 50 in front. It is not 50. Let us consider it as some 15 or 5, whatever it should be. It's not 50. Let us consider it as some 5 or 15 or 10, whatever it should be. I just consider some 15. So this becomes locus of 15. Why? Because in front VP means below XY line. Okay. So when you are going to see from the top view, let us see. This was the solid. It like this. When you see the top, you see the true shape which is projected on rotating horizontal plane 90 degrees clockwise. You will going to be obtain like this. Okay. Or here you are going to obtain your square. So this was your square. Let us give your points. So this is how many points? Let us see. This was A, B, C, D. Is that okay? Is it correct? My points are correct? When I am seeing from the top, I notice the square shape ABCD. Is that okay? Is that okay? Is it right? No, it's not right. Let us see why. Here it is a square prism. It is a square prism. Prism means how many bases? 1 and 2. If you see from the top, this base is visible, that is ABCD, let us consider it as visible. Then PQRS is invisible, which is going to be resting on HP. When you see from the top, these four corners are visible, bottom four corners are going to be invisible but existing. So while you are going to see from the top, these four corners are represented with the visible points, bottom four are going to be invisible. So I put my those points on bracket. So this becomes, in bracket it is P Q R S. P Q R S. And now let us consider the center, where you are going to put your center. If you join your two diagonals, you will get a center. I just put my center at here. Okay. So what is the center means? You are going to consider the axis. How can you obtain the axis? Centers joining base 1 and base 2. These two centers are, let us consider it is O1 and O2. While you are seeing from the top, O1 is visible. Okay. O2 is invisible. So I just consider it as O1 of O2. Now, if I draw the given height of the axis is given as, side is given as 20, okay, and height is given as, height of the solid is 50. So in which view you are going to see the height? If the position of the solid is like this, top view gives the true shape of the solid, front view gives the height. Okay, so what was the height of the solid? I just extend my axis like here. I just draw my axis. So this was the given height of the solid 50. So I just extend my axis. So that means this was the height. If you draw the projectors from here and join this. Okay, this was the front view. When you are going to see from the front, if you just put like this, then let us tell me what are the visible points. This was, top is nothing but ABCD, bottom is PQRS. Top points are B dash of A dash. Why? Because here it is going to be ABCD. Here the prism ABCD PQRS. Top few points are ABCD, bottom are PQRS. So while you are going to see from the front, B of A, C of D. Okay. So B dash of A dash, and similarly this becomes C dash of D dash. Similarly, the bottom base points are, this becomes Q dash of P dash. Why? Because when you are going to see from the front, these two corners are visible, these two corners are visible. These two. That means, let us see, BC and QR are visible. So similarly, Q dash of P dash, and similarly R dash of S dash. Okay. So from the front, you are going to see the height. Okay. And also the axis is going to be, here it is O1 dash, here it is O2 dash. In front of you, the points are with the dash. Okay. Always you just remember, axis is going to be represented by line, a dot, line, a dot, line, a dot, line, a dot. So this is going to be the axis representation. Students, is it clear? Is it okay? Have you understand this? So many had put their thumbs down. Why? Because, okay, let us see. Students, let us see the construction of simple position of the solid. I just put my solid like this. I'm supposed to see the front view and top view of the given solid. So front view and top view. So front view and top view means top view gives the true shape. That was the square. Top view square. Front view you are going to see a rectangle. That is I am just represented. Top view you see the square. Front you see the rectangle only. Okay. So why you just obtain these 8 number of points? All of you just see. Solid is going to be resting on HP such that one of the edge is going to be that means nearest edge to VP. What is the nearest edge to VP? If I am VP, nearest edge to VP is this was the farthest edge and opposite to this. Okay, so this was the nearest edge to VP. Okay, so this nearest edge to VP, it is going to be some 15 mm in front, resting on HP. At the same time, it is not supposed to touch the VP. It is some 15 mm in front of VP. So how it is in front means the nearest edge to VP is, if it is VP, this edge is going to be nearest. It is 15 in front. It is 15 in front. So top view gives the true shape. So while you are going to see the top, you see A, B, C, D. But prism having two bases, 1 and 2. Top base is visible, bottom base is invisible. So A, B, C, D are visible from top view, and P, Q, R, S of the bottom base are invisible. So I just put it as in bracket. A, B, C, D are visible, P, Q, R, S are invisible. Similarly, while you are supposed to see from the front, you notice the height of the solid, which is given as height of the solid is 50. So I just from XY, I just draw a line of 50 and I just draw another locus. If I draw the vertical projectors from here, these two are going to be meet at 50 locus, and if you join all the points, you will obtain a front view as a rectangle, as like you. Here, if you see, these are going to be your rectangle. Okay, so in this rectangle, if you can say A, B, C, D, so while you are going to see from front, here you are going to obtain 4 points, here you obtain 4 points. If you see from front, it becomes B of A, it becomes C of D. Similarly, it becomes Q of P, R of S. So front view is going to be with dash. So front view are going to be considered as B dash of A dash, C dash of D dash on the top base, and Q dash of P dash and R dash of S dash in the bottom base. Okay? Okay, students? Now let us see another simple problem. A square pyramid of side 30, square pyramid of side 30 mm and axis 50, axis or height both means the same, and axis 50 mm. Axis is nothing but, why axis and height is same? Axis is nothing but joining the bottom base and top base for prism, or joining the center of the bottom base and apex for the pyramid. So that means your height of the solid. Resting on its base on HP, resting with its base on HP such that one of its edge of the base is parallel to such that one of the edge of the base is parallel to and 10 mm in front of VP. Writes projections. Okay, students, let us just follow a square pyramid of side 30 and axis 50 mm resting with its base on HP such that one of edge of the base is parallel to and 10 mm in front of VP. So let us consider this was the square pyramid. How can you say it is a square pyramid, sir? The base shape is of square and I can say it as a square pyramid. Having your base side is of given us 30. Side is 30 and axis height is 50. That means height of the solid is given 50. Height of the solid. Next, resting with its base on HP. It is sits on HP. Okay. Next, such that the one of its base parallel to and 10 mm in front of VP. So base edges are nothing but here are the base and edges are nothing but base edges. Don't confuse to the base edges and slant edges. These are the slant edges and these are the base edges. Base edges are straight edges which are perpendicular to each other. Base edges. So one of the base edges is parallel to and 10 mm in front of VP. So what is that? So this edge. So you are going to see from front. This edge is going to be also parallel to VP. Okay, now it is parallel to and 10 mm in front of. I just consider the opposite edge of this. That is in this direction. It is this. This edge is okay 10 mm in front of VP. 10 mm in front of VP, and it is resting on HP. From VP, it is 10 mm in front. Okay, so which is resting on HP means axis is resting on HP means axis is perpendicular to HP. Okay, so when your axis is perpendicular to HP, true shape of solid seen in top view. If it is resting on HP. Resting on HP means axis is perpendicular to HP. So axis perpendicular HP means you have to see the top view to obtain the true shape of the solid. So what was the solid true shape? It was a square pyramid. So square is going to be seen from the top. Okay. So if the resting on VP, if axis is resting on VP and vice versa. Resting on VP means, if it is resting on VP means axis is perpendicular to VP. Axis perpendicular to VP means front view gives the true shape of the solid. Okay. Now let us see the simple position. So given XY and it is 10 mm in front of VP. So I just draw the locus of 10. Okay. So from here I just construct my square. Okay. So tell me the points. Let us consider. I just consider A, B, C, and it is D. Tell me what are the remaining points that we obtain. Tell me, what are the remaining points that we obtained? So while you are supposed to see from the top, I notice a square. Tell me another, any other points? Anybody? What are the remaining points that I had to place there? Exactly, number 208 of ECE, very good. So very good. Why? Because means if you just take your pyramid, okay, while you see from the top, you just see the apex and also the edges which are joining apex to the base. These slant edges are going to be seen from the top. So first of all, I just put my apex. First of all, this was some O1 of O2, and I'm supposed to join all the corners to the apex like this. So that means while you are supposed to see from the top, let us see. If you are going to see in this manner, you have to join the apex to all the corners of the base edge. For the pyramid, let us see. So I get only one set of points. If the for a prism, I just get two set of points. Why? Because two bases are there. While coming to here, only one base and apex, and joining all the corners of the base edge to the apex. And I know the height of the axis, which is given as height of the axis which is given as 50. Okay, and when you are going to see from the front, what are the points which are going to be seen here? Only base points are going to be seen. These points becomes, this is B dash of A dash and this is C dash of D dash. Now join these 2 points, you will obtain the straight edge, and this becomes your O1 dash and this is O2 dash. Now join O1 dash with O1 dash with here. So this becomes your front view, this becomes your top view. So tell me, let us see, if you write like this, you are going to be seeing only your triangular face in front of you. While you are going to see from the top, you are going to see the base square and also
సార్ బోర్డ్ కొద్ది కింద కనండి సార్, ఇంకొద్దిగా. ఇంకొద్దిగా సార్. ఓకే ఓకే.
Students, is it audible now?
ఎస్ సార్.
Screen is not visible right now. Now it is visible. Is it visible now?
సార్ స్క్రీన్ కనపడట్లేదు. స్క్రీన్ ఇట్ నాట్ విజిబుల్ సార్.
Had you copied the problem? Can I move to the next problem? Can I move to the next problem? Okay, all of you write the problem. Draw the projections of a regular pentagonal prism. Draw the projections of regular pentagonal prism. Side of base side 30 mm. Pillar pentagonal prism. Side of base 30 mm and axis 50 mm. Resting its base on HP such that one of the rectangular faces is perpendicular to VP. Right predictions. Students, is it visible? Okay. Regular pentagonal prism, side of base 30 mm and axis 50 mm, resting with its base on HP, such that one of the rectangular faces is perpendicular to VP. So let us see, as like the previous problems which we did, regular pentagonal prism means having the base shape of a pentagon. Next, base side is 30 and axis is 50 mm height. So if I just didn't consider this, if I didn't consider axis, then it becomes, and one of the, if I didn't consider this rectangular face, and it is going to be considered as a simple plane having a pentagonal prism, side of base 30 mm. So I just consider pentagonal surface, side of base 30, resting with its base on HP. So that means always you just know that when it is an edge resting problem, you are supposed to start that from the edge. So that means here it is axis perpendicular to why? Because resting with its base on HP means axis is, that means axis perpendicular to HP. When your axis is perpendicular to HP, let us see, it was a pentagonal prism of side. Resting on HP means top will use the true shape. And it is a edge resting problem. Always you just consider, if you start from the edge resting problem, the edge must be perpendicular to XY. That we already discussed in the plane. The same concept here also. While you put your edge like this means your rectangular face is perpendicular to VP. Let us see here. If I put like this, so this edge is going to be perpendicular to XY means if you join this edge and this edge, you obtain a rectangular face. This rectangular face is perpendicular to VP. Okay. So furtherly, always when you start the problem as a edge resting problem, you just draw that the edge must be perpendicular to XY. Okay. Now mark the points A, B, C, and also top view you are going to obtain the true size and shape. True shape was base 30. Okay, and here it is a prism. So particularly I get the double points. Why? Because so top base is visible, bottom base is invisible. So I just place it as bracket P, Q, R, S, T. And how can we obtain your center? Let us take your center is going to be obtained simply by take one of the corner and join the opposite side. Okay, corner is here. The corner opposite is going to be here. This was the side. So I just draw this perpendicular, and if I take from this corner and if I draw the perpendicular, we'll get the center. Okay, so this becomes over now. Now draw the axis. Height of the axis is given. What was the height of the axis? Height of the axis is given as T. Okay, and now just draw the vertical projectors on the so these two will coincide, these two will coincide, this will obtain like this. Okay. And now draw the extend the projectors up to this was the top base, this was the bottom base. So for prism, I have two bases while you are going to see from the front. Let us see. If it is the front, when you are going to see from the front, you have bottom base, top base. Okay, when you see from the front. So simply I just extend this projectors. Okay, and erase the excess portion. Now tell me, what are the top points and what are the bottom points? So if we let's see from the top, A, B, C, D are visible means this was the top base. P, Q, R, S is invisible means this was the bottom base. Okay, so let us see. What are the visible points you are going to have in this was? B dash of B dash. Next is because C dash of B dash and it is dash. While coming to here it is Q dash of B dash, R dash of B dash is S dash. Now join all the points. Always when you are going to see from the front is going to be your solid outline. See from the front. Okay, and this becomes your one dash. This dash. Okay, students, is it clear now? Is it clear? Okay, let us see another problem. A hexagonal pyramid, side of base 30. Hexagonal pyramid, side 30, height 50. Height of the axis. Even hexagonal pyramid, side 30, and height of the axis is 50. Resting which is based on HP. Resting its base on HP. Such that one of the edges of base is parallel to such that one of the edges of the base parallel to and 10 mm in front of you. Five solutions. Okay. The students, first of all, while you see the problem, you just hexagonal pyramid means in yesterday's that is discussion of planes also we see that when we get the hexagon means the shape must be either, it should be one case and this should be one case. So which is going to be considered? So this was the edge resting and this was the corner resting. Okay, so while you are supposed to place the single position, you just have to place your concentration. If it is not going to be given, means the total problem is wrong. So in place of this, if you just consider this, you will get 0. In place of this, if you get place this, you will get 0. Okay, but how can we put our hexagonal pyramid in the simple position when you are going to see from the top? So that means always in this kind of consideration, let us see the given problem. Base on HP such that one of the edges of the base parallel to and 10 mm in front of VP. That edge must be parallel to XY. So that means parallel to 10 mm in front of VP. So when you are concerned, the edge must be parallel to VP means there should be parallel to XY only. Okay, so whenever if it is parallel to like this, it is parallel to XY, then only it should be parallel to VP. If edge is going to be like this, means it is perpendicular to HP, not perpendicular to VP. Okay, so I just require my base edge which is resting on the ground. Base edge which is resting on the ground base is going to rest on the ground is like this. Okay, so you just go for this. Why? Because that means the base edge is going to be parallel to and 10 mm in front of VP. So 10 mm in front of VP means there should be always something below XY. That should always come below XY. So that means, so one of the base edge is going to be on here. Okay. Okay, so here it is a hexagonal pyramid. Don't get confused. So how many set of points you have taken? Only one set of points. So that means A, B, C, D, E, F. So gives the side is going to be given as 30. Okay, and I just consider my center is going to be which is going to be joining the two diagonals. I am going to obtain my center. This is going to be your center. This is O1 of O2. So this was a hexagonal pyramid. Hexagonal pyramid. So while you are seeing from the top, you notice the base shape and also apex joining all the base corners. Okay. Okay. Now, what was the height of the solid which is given? Which is given 50. So first of all, I just draw the axis line from my origin. So I just have to measure from XY it should be 50, right? Because the base is going to be on HP. So that means while you are going to see from the front, the base is going to be on XY. So from XY, the height of the solid is given D. Okay, so this becomes O dash and this becomes O2 dash. Now project all the points to the XY. Why? Because all the points of the base are going to be weighed on XY. are the vertical projectors from all the points that will meet on XY. Now, if you join all the points, you obtain the base. What are the visible points when you see from the front? What are the visible ones? A, B, C, D are visible. So this becomes A dash, is B dash, in bracket it is F dash. Similarly, here it is C dash, in bracket E dash, and it is D dash. Now join all the points. Okay. So this was the front view. That means when your hexagonal prism is pyramid is going to be on HP, while you see from the front, you are going to be noticed like this. When you see from the top, you should be seen like this. Is it clear? Students, is it clear? Students, is it okay now? Okay. Students, shall we move to the next problem? Shall we move to the next problem? Okay, all of you write a column. A square prism side of base 30. height 50 mm. Resting with its base on HP. Resting with its base on HP such that one of the rectangular faces is inclined 30 degrees to BP. Inclined 30 degrees to BP. Right solutions. So tell me the given data. What is the given data? Is it audible now? Is it audible? Is the screen visible? Is the screen visible for you? Is it okay now? Is it okay? So for me, it's completely visible. Now is it okay? Is it okay now? Okay, I just complete this problem and I will stop for today's session. Okay, so The square prism is given side of base 30. Let us see, this was a square prism. Given side of base 30 mm. And height is given 50. Height of the solid is 50. Resting it is based on HP. Base is on HP right here. Such that one of the rectangular faces is inclined 30 degrees to VP. One of the rectangular faces is inclined 30 degrees to VP. This was the rectangular face. So always you see that VP inclination is going to be like this only. If it is your VP inclination, it should be made inclination like this only. So that means which is going to be made the inclination, the edge which is resting edge here is to be made inclination. Okay, so draw its projections. So first of all, so you just place your prism in such a way that one of the edge is going to be making inclination 30 degrees, the base edge inclination. 30 degrees means obviously your rectangular face is also making incline. So which is inclined to the 30 degrees. Okay, so I just take that concept and I just do that. Let us see first. I just draw a line of XY. So given inclination is 30 degrees. So draw a line of 30 degrees. Okay, such that my edge is going to be resting on this 30 degrees. So that means okay. Now mark the points. Let us consider is A, B, C, D. Other work. It is P, Q, R, this. Why? Because it's a square prism. Okay. Now put your center of the square prism for obtaining an axis. I just joined the axis. Now I can obtain my center. Okay, so this was for my reference only. Let's do this for my reference to obtaining the center. This becomes O1 of O2. Now I just draw the axis from center. I know the height of the axis is given as height of the axis is 50. Side is given as 30. Height of the axis is 50. This is given 50. Okay. Now draw the front view by extending the top view points to obtain the front view. Okay, and extend this. Now, that is the axis points. Okay. Now join this. Now join all the points. Okay. Now you can see when you are going to see from the front, A, B, C, D are the top points. Let us see which points are going to be visible. A, B, C are visible and D of S is invisible. Let us first of all put the points. So this becomes A dash and this becomes your B dash and this becomes your C dash and next D point is going to be invisible. Why? Because if you are going to be seeing this manner, while you are going to see 1, 2, 3 corners are visible, this behind the corner is invisible. So this D point is going to become in bracket. That is in bracket it is D dash. Similarly, here it is also D dash, D dash, and here it is U dash, here it is R dash, and it is S is in bracket S dash. And you can see this. While you are going to be seeing from the front, visible corners are going to be seen. The lines which are going to be joining the top and base corners, that is A and B are going to be visible. So it is a straight line. It is a visible solid line. P and Q are visible. So B dash Q dash is visible solid line. C R is visible solid line, but DS is not visible. So I just put it bracket. So you just represented by dotted line. So this dotted line represents your line which is invisible. Okay. So this becomes your 1 dash center. Students, is it clear? Is it clear now? Do you understand this? So all of you just copy this problem, and this was the simple positions. These are the kind of simple positions for placing solids. And in the next session, we will discuss the solids inclined to one reference plane and both the reference planes. Okay, in next class we will discuss the solids inclined to one reference plane and both the reference planes. Okay. Okay, students, thank you. Thank you so much. Participants are only just 32. So at least for next class, which is the most important class for the projection of solids, so kindly maintain the maximum attendance for the next session. Okay. Thank you.